You know the story, right? A huge, exciting software project gets the green light, but somewhere down the line it just goes off the rails. It ends up wildly over budget, or it delivers something that nobody actually wanted, or it just fails completely. It happens way more than you'd think. And the problem, the real root of it, is almost always right there at the very beginning, in the blueprint. So today, we're going to talk about how to get that blueprint right. And look, this isn't a new problem. The software engineering legend Frederick Brooks absolutely nailed it with this quote. The hardest part isn't the coding, it's not the testing, it's deciding precisely what to build. If you get this part wrong, it doesn't just create a small problem. It's like a crack in the foundation that cripples the entire system before you've even laid the first brick. And this isn't just a feeling, it's a hard, expensive fact. Research from guys like Bohm and Basili actually put a number on it, and wow, it's staggering. Fixing a mistake in the requirements after the software is delivered can be up to 100 times more expensive than catching it right at the start. That's not 100% more, that is a 100-fold increase. The stakes, well, they could not be higher. So how in the world do we avoid those 100x mistakes? Well, the answer is to build a rock-solid foundation. And that foundation starts at the very first step of the whole software development lifecycle. You have to clearly, and I mean clearly, define the requirements. Before a single line of code gets written, we have to know exactly what we're building. Now, at its heart, a requirement is a pretty simple idea. It's just a statement of something the product has to do, its function, or a quality it must have, like being really fast or super secure. But don't let that simplicity fool you. That one little statement carries an enormous amount of weight. It's the core blueprint that guides every single decision from here on out. And we can break these requirements down into two essential types. On one side, you have your functional requirements. These are the whats. What does the system do? It calculates a total. It saves a document. It searches for records. Think of them as the verbs of your system. And then, on the other side, you have the non-functional requirements, the hows. How well does the system do its job? Is it secure? Is it fast? Is it easy for a real person to use? You absolutely need both to have a great product. Okay, I get it. Just saying define the requirements can feel a little abstract. So we need a real practical tool to get this right. And this is where a really powerful technique comes into play, one that's designed specifically to nail down those all-important functional requirements. It's called the use case. A use case is really just a story. That's it. It's a short story that describes how a system behaves from a user's point of view. It always has an actor, which could be a person or even another system, and that actor is trying to achieve a specific goal. By turning requirements into these simple stories, we make them real, tangible, and honestly a lot easier for everyone on the team to understand. So every one of these little stories has 4 core parts. You've got the actor, who is using the system. Then there's the goal, what are they trying to get done? You have the system, that's the software we're actually designing. And finally, you have the main sequence, the step-by-step conversation between the actor and the system. When you put it all together, every use case answers one simple, powerful question. Who is using this thing and what do they need to accomplish? All right, let's make this crystal clear with a classic, everyday example that I think we can all relate to, just using a cash machine, an ATM. This super simple scenario is actually perfect for showing how a use case works in the real world. Okay, you can see that story playing out right here. The actor is the customer. Their goal is to withdraw cash. So step 1, the customer puts in their card. Step 2, the system asks for a PIN. Step 3, customer types it in. Step 4, the system checks the PIN and shows the menu. Step 5, the customer hits withdrawal and punches in an amount. And finally, step 6, the system gives them the cash and a receipt. This simple back and forth is what we call the happy path. It's the ideal scenario where everything just works. It's a perfect little story for one specific function. Okay, so we've got the basic idea down. Now, let's level up and see how this applies in a more complex, real-world situation. We're going to look at a warehouse company called Starphone and explore how use cases can actually work at different levels of detail. And this is a really important distinction. On the left, you've got the business use case. This is the big picture. It's just about the business process, and it doesn't care about technology at all. A customer calls, the warehouse sends out the goods, the customer pays. Simple. But then on the right, we drill way down into the system use case. This gets into the nitty-gritty of how a clerk actually interacts with the software to make that process happen. Entering an item number, having the system calculate tax, all of it. So, how do we make sure we've actually covered all our bases? We create an actor goal list. This is a brilliant, systematic way to think about every single person or thing that touches the system. We don't just think about the customer. Who else is involved? Well, the warehouse staff needs to dispatch orders. The driver needs a delivery list. By listing out every actor and what they need to do, you start to uncover these essential requirements you might have totally missed otherwise. All right, so after that quick tour, let's boil this all down. What are the key takeaways here? What are the most important things to remember about why this stuff is so vital for any project you work on? Here are the core principles you need to know. First, one use case equals one goal for one actor. That's it, keep it focused. Second, any real system is going to have a whole bunch of use cases to describe everything it does. Third, remember, they work at different altitudes, from the 30,000-foot business view down to the on-the-ground software interaction. And finally, just remember, they are the best tool we have for modeling and truly understanding the functional requirements, the whats of your system. And that brings us right back to where we started. This isn't just some academic theory. This structured way of thinking, of identifying actors, defining their goals, and mapping out the story, this is the practical, proven way to get the blueprint right from day one. This is exactly how you get ahead of the curve and prevent those ridiculously expensive 100x mistakes. So, to leave you with a final thought, here's a little challenge. Pick an app you use every single day. Could be your banking app, Spotify, Instagram, whatever. Just for a second, try to think like a designer. Who are all the actors involved? Not just you, but maybe others. And what are the core goals, those fundamental use cases that make that app actually work? It's a fascinating way to start seeing the software that runs our world in a completely new light.